Hello, here's the second podcast in Chapter 4 talking about SSS and SAS congruency. And it's really important that we talk about congruent triangles just because triangles, again, are considered the most stable of all shapes. We use them a lot in our buildings, in our bridges, and that's just a really important thing to talk about. So we're really, again, looking for why do things need to be congruent, and so we're going to basically focus on triangles using our two new postulates. So here they are. Postulate SSS, which is also called side, side, side. SSS is just the abbreviation for it. And again, you can read what it says. Basically, in essence, you're having three pairs of sides that are equal. In postulate 4.2, which is SAS, that's side, angle, side. That's when we have two pairs of sides that are equal, and we have the angle nestled in between the two sides to be equal. But the key thing is that that angle must be in between the two sides. Otherwise, it's not SAS. The A would be in a different place, and it would spell a naughty word. So just to share. So this is what a brief look like what SSS and SAS look like. So just to kind of, again, we have three pairs of sides equal with the SSS, and then the SAS, again, notice how that angle though is right in between the two equal sides. So that's really important. So we're going to focus on if we've got an SSS or an SAS, or if we don't, then it just could be a none. And we're going to talk about that. Now, before we do that, though, there are two things, and I want you to write this down, two things we can always assume. We can always assume, number one, that if we've got vertical angles in that picture, they have to be congruent, because vertical angles are always congruent. We've been talking about that since chapter 1, so we should have that under our belts. Second thing, if the triangles share a side, because many triangles do, that side has to be equal to itself, which we call reflexive. And we actually briefly talked about that in the last podcast, if you remember. So let's get going and start looking at some of these triangles. So for number one, do you see we have a pair of sides right here and here, a pair of angles, and notice, something we can assume. We've got a side they share. So are these triangles congruent? Yes. Why? Okay, side, angle, side. Always check both triangles. Side, angle, side. So this would be an SAS. Again, notice that angle is really nestled in between those two sides. So that's really important. Okay, number two, we've got angle and a side again and an angle. Again, we share a side. Side, angle, side. So wait a minute, let's look at this other triangle. Side, angle, side way over there. That angle's in the wrong spot. That angle should be right here, and it's not. So if your triangles don't match up on both sides in the same language like SAS, then therefore you don't have anything. So these triangles are actually not congruent to each other, so they're nothing. Number three, they share a side again, so we got that. A pair of sides, and a third pair of sides. So this would be S, S, S. Okay, number four. 3 marks, 3 marks, 2 marks, 2 marks, 1 mark, 1 mark. Oh my goodness, another SSS, 3 pairs of sides equal. Number 5. We got 2 pairs of sides. They don't share a side. We just don't have enough information. We don't have another angle or a side, so this is just going to be none. And for number 6, again, they share a side. So side, angle, side, side, angle, side. So some people have mentioned, they're like, well, wait, Mrs. Cable, the angle markings don't look quite the same. They are the same marking. If it looks like the same marking, they're equal. So don't let that bug you. Okay? So that's kind of our basics, being able to look at the pictures. Now, here's the second piece. Now, this is going to lead you to the important part, which is kind of leading us into a proof. Now, if we want SAS, look at what we're given and see what additional piece do we need? So here I want to prove SAS. Notice what I've got. I've got two pairs of sides. So I really have two S's done. That S is done, that S is done. So all I need really is an angle. Now be careful, that angle needs to be nestled in between the sides. So in order for that to work, I would need this angle because it's nestled in between, and this angle nestled in between. Now it's all set and good to mark the drawing, but you really need to write it what the statement would be. So what additional information would I need to know? I would need to know that angle X is congruent to angle R. That would be enough information to prove SAS. Let's look at the next one. I want SSS. All I've got is this pair of sides, BM and LK. Well, I got one S taken care of. Wait a minute, I've got a sharing of a side, so that counts as a side. So what piece I need is just this piece to be equal to that piece. Now we need to say it. So BK is congruent. Now be careful when you're matching. Notice B is by this two little tick mark. So really, it's going to be LM. I have a feeling some of you guys would write ML. So therefore, be very careful when you match. That's really important. All right. So when we look at a proof, and I know you guys are thinking, proof. It's not that bad. To me, like triangle proofs rank right up there with algebra proofs. They're not bad. So here we have the given. See? Okay. And we also have some vertical angles in here. And think about what does that mean if L is the midpoint of KM? That means it's going to cut it in half. So therefore, this piece is equal to this piece. Lo and behold, these triangles are equal. And you could look at them now and say, oh, Mrs. Cable, they're congruent because of SAS. And I'd say, you're right. And this is what that proof would look like. So again, saying that the original two sides are equal. Got the given of the midpoint. Then again, the vertical angles we found. Then again, saying what two sides were equal because of the midpoint, and then saying SAS. So again, don't let proofs bother you. They're actually pretty basic. I mean, we're looking for a side or we're looking for an angle. I mean, it's not super duper fancy. Here's another example. So for this example, I'm going to have to change to my arrow key here. Here we've got some stuff given. And if something's given in the picture, it's given. So if you see it in the diagram, it's a given piece of information. So SQ is congruent to PM. See how that's nicely marked already? And then these two are equal. So angle SQM is congruent to PMQ. That's given. Because again, it's in the drawing. Again, do you see? They share a side. So that counts. So QM is congruent to QM. Again, that's called reflexive. And then if I mark it, which I don't have my pen on right now, but if I'd mark this, side, angle, side, side, angle, side. So you can see that that's why it's SAS. So again, don't let triangle proofs bug you. Here's the last proof we're going to do, and I'm going to need to go back to do my pen. Here's our fancy-dancy flow chart. Again, I have the drawing down here, and the one thing I cannot emphasize enough is to mark your drawing. You will see whether it's SSS or SAS as long as you mark the drawing. So this is our given information. That's why I made it in a different color. So we are given that PR and QS bisect each other at T. That's given. And now we got some work to do. So think about, what does bisect mean? Well, bisect means we're going to cut it in half. So therefore, if PR is being bisected by T, that means these two pieces are equal. And then it also says that QS is being bisected. So therefore, this piece is equal to that piece. So notice it's got the QT is congruent to TS already in definition of bisect. Notice we've got PT is congruent to TR. Now we need a reason for that. There's a line there. Well, wait a minute. It'd be the same reason as the other one. So take the same reason, definition of bisect. Okay. Oh, tells me some vertical angles are congruent. You're right. There are some vertical angles in here. And we should name them. Now, you can't call it angle T, guys. There's more than one angle at T. So PTQ, looks like a nice way to say it, is congruent to angle. Now, be careful. P is by the two arcing mark. So this triangle must be flipped. So this would really be angle RTS. And then now take a look at our picture. Why are the triangles congruent? Side, angle, side. End of the proof. So this is our summation of, again, SSS and SAS postulates. Next podcast, we're going to mosey on to the next two, which is ASA and AAS. And have a great day.